Hey everyone, welcome back to another reality check. Today let's take a look at an important type of exteroceptive sensors, range sensors. Now range sensors are important for mobile robot applications because they provide the robot with situational awareness, right? And this can be important for applications like navigation or obstacle detection. Now there are different types of range sensors. They can come in the form of radar, LiDAR, sonar, depth cameras, stereo vision cameras, and even time of flight using either light or sound. And the type of sensor that you choose really depends on the application. Now there are many factors to consider when selecting an appropriate sensor. Now the usual technical specifications like range, field of view, resolution are all important. But in the real world, we need to factor in conditions like the environment and cost as well. So for example, think of an underground mine. These environments are deep, dirty, dark, dangerous, and damp. So we obviously need our sensors to work in such harsh environments or our robot's not going to be able to see, right? So how do we do that, you ask? Well, we look at the sensor's ingress protection rating, or IP rating. So the IP rating basically uses 2 digits to define the level of sealing effectiveness of electrical enclosures against things like solid objects and moisture. So the first digit rates the sealing effectiveness against solids, starting at 1 for sealing against objects greater than 50 millimeters, all the way to 6 if the seal is dust tight. And then the second digit rates protection against moisture, and it starts at 1 for protection against vertical falling drops, so for things like rain on a calm day, and all the way to 8 for watertight for long periods. Most of the sensors we will look at today are rated IP67, which means dust tight and watertight at depths up to 1 meter for 30 minutes. So let's take a look at a few ranging sensors that are found on robots today. Okay, so the first up is the Xbox 360 Kinect, and this is a depth camera. So how it works is by first it shines an infrared grid onto a surface. Now, if you shine a 2D grid onto a 3D surface, it's obviously going to get distorted, right? So what this camera does is it basically captures that image and then does some processing to convert that grid into a depth map. Now, the sensor has a decent range at 4.5 meters, but it has a low resolution and a narrow field of view. And it obviously doesn't have an IP rating because it's made for household use as a gaming controller, right? It's popular in indoor robot applications, but this thing would probably not last an hour inside a mine, right? But hey, it only costs $100. The data is pretty noisy, and it doesn't really perform well in sunlight. And like I said, it's good for indoor and laboratory robots, but it's not really useful for high accurate navigation and mapping. So next up is the new Kinect for the Xbox One. And this sensor offers better specs compared to its older brother overall, with better resolution and a larger field of view. But it costs a bit more at $150. And it actually works on a completely different technology called time of flight. So basically, there's a sensor here that emits an array of pulse light, and it measures the round-trip time that it takes for the light to travel from a reflective surface and return. And then, since we know the speed of light and the time it takes, we can calculate the distance. It's relatively new to the market, so roboticists are still working on applications using this guy. But the reviews are mostly positive. Once again, this is somewhat of a toy, right? So it doesn't have an IP rating, and it probably won't last in a mining application. But it's still suitable for indoor and laboratory applications. I think it performs a little bit better than the older Kinect in sunlight, but the measurements are still pretty noisy. So it's not suitable for serious robotic applications. Now what's interesting is actually this sensor, which is called the Swiss Ranger SR4000. And it's also a time-of-flight camera similar to the Kinect, but it's a few years older. It has the same specifications in terms of range at the same frame rate as the Kinect, but it actually has a worse field of view and a lower resolution. But the thing is, this sensor costs $10,000. So what's the difference? Well, it's actually, this sensor is rated for IP67. So it's a bit more ruggedized, and it will survive dust and moisture, whereas this one probably wouldn't. Okay, so next up is the SICK LMS111 2D laser scanner. And this sensor basically consists of a high-powered laser, emitter, and receiver. Now the laser is shot into a spinning mirror which sweeps the laser 270 degrees, and we obtain depth measurements at every 0.25 degrees or 0.5 degrees depending on the scan frequency, and it has ranges up to 18 meters. So if we attach the scanner on our Husky robot and drove it around, we would probably get a 2D scan like this. Now this sensor is pretty rugged, and it has an IP rating of 67 and retails for about $5,000. And these are already very popular in serious mobile robot applications for navigation, 2D mapping, and localization. So finally, we have the Velodyne HDL32E, which is a 3D laser scanner. And it works basically the same principle as the SICK LMS111, but instead of one laser, it shoots 32 lasers, and it sweeps 360 degrees. So we get this nice depth map of our surroundings. Now the Velodyne has a much greater range at 70 meters, and it's also rated IP67. Now this sensor actually sells for about $35,000, and it's already popular for autonomous driving applications like the Google car. And it's kind of funny because it costs almost as much as a car. So these are a few examples of popular ranging sensors that are used on robots today. As you've seen, it's not only important to consider the technical specifications when selecting an appropriate ranging sensor, it's also important to consider the working environment as well. So for example, if you're working in an underground mine, you might want to consider a sensor that's more rugged and with a high IP rating, like the Swiss Ranger. And if you're working on a robot in the lab or indoors, then we might be able to get away with using a ranging sensor like the Kinect, for example. And that's it for this reality check. See you guys all next time.